Okay, so let's continue this. Let's start filling out this expression over here for the sum of the electric fields in the x direction over here. So it's going to erase all of this, right? And move this over to the side just a little bit. And now we're going to take a look at our two triangles here. We're going to pull them out of context here, just so we can see them better. We see this is our electric field E2. This is our right angle. This is our theta. Likewise, we also have another one over here, except this one is E1. That is E1y. This leg over here is E2x. This leg over here is, this one over here should have been E1x. This here is E2x. And this one is E2y. Now, let's look at just those x components. As we said, they're in opposite directions, and there must be subtraction. And if we look at the triangles carefully, that is adjacent to the x component. So using our trigonometry, we see E1 times cosine of theta minus E2 times cosine of theta will equal to the sum of our electric fields in the x direction. Now, I can also just as well do this for the sum of the electric field in the y components as well. I can say E1 sine of theta minus, well, in this case, those two electric field components are pointing in the same direction, as we see over here. So, unlike the x components, which point in opposite directions, the y components are going to add because they're pointing in the same direction. So, plus E2 sine theta is equal to the sum of the electric fields in the y direction. Okay, now we're going to define what E1 and E2 are, respectively. So E1 is equal to K times Q over R squared. And remember what that R was. That is the distance from the charge to our point in space. We want to know the electric field. And we had verified, based on our diagram, that at least for E1, that it is R1, which is A root 5. But R1 is also the same as R2, which is also A root 5. So, if I go back here, I see that E2 is equal to K times Q2 over R2 squared. And both of these guys are going to be K Q1 over A squared times 5. And E2 will be K Q2 over A squared times 5. So all of this can be plugged into our expressions above. So let's go ahead and make that substitution. So for the EX part, just going to do this really quick. So maybe you'll see the details. Maybe you won't, but I encourage you to do this on paper. So K over A squared is in common in both terms for the x components. So I can then do Q1 cosine of theta minus Q2 cosine of theta. And for the y components, down here, it will be the same scenario. K over A squared times Q1 sine theta plus Q2 sine theta. Okay, so we'll keep further developing this in the next video.